Demodulator is a circuit which is used to recover the original modulating signal from a received signal at the receiver side. So at the receiver side, we want to recover the original message signal to be transmitted. So for that we are using the process called demodulation process. It is the process of extracting the original message signal from the received signal. It is the reverse process of the modulation at the transmitter side. AM demodulators are also called as detectors. Types of AM detectors: linear detector, nonlinear detector. The example for this nonlinear detector is square law detector, and here we are going to use the non-linearity property of the semiconductor diodes or transistors. So next, linear detector is further classified into coherent detector, non-coherent detector. So coherent detector, we are going to synchronize the carrier signal generated at the receiver side to the carrier at the transmitter side. So both the carriers should be synchronized with each other. So here the example for this coherent detector is synchronous detector. Next, non-coherent detector. Here there is no dependency between the carriers in transmitter and receiver. Example for this non-coherent detector is envelope detector. So in this video lecture, I am going to cover envelope detector. Envelope detector is also called as diode detector. Here we are going to use the linear property of the diode. The envelope detector is a linear detector which produces an output signal that follows the envelope of the AM wave. Here the output signal is nothing but the original message signal. In this detector, a simple diode operates in a linear region of its characteristics to extract the envelope of an amplitude modulated wave. So this is the circuit diagram of the envelope detector. Here we are going to receive the amplitude modulated signal S of t and given as the input to the diode. So based on the diode characteristics, we can obtain the envelope of the AM wave at the output side. From that we can get the original message signal using low pass filter. So here C is nothing but filter capacitance, RL is the load resistance. During positive half cycle of the AM signal, the diode is forward biased and acts as a closed switch. So if it is closed means the capacitor charges to the peak value of the input signal. So that is the first point. So whenever the positive half cycle is coming, okay, positive cycle is coming, the diode is in the closed condition. So here diode acts as a switch, so it is in the closed condition. So at that time the capacitor charges to the peak of its positive cycle. Okay, so likewise during the negative half cycle, okay, during this negative half cycle the diode is reverse biased. At that time it acts as a open switch. Okay, so it acts as a open switch means the capacitor discharges through RL till the next positive half cycle. So that is the property of this circuit. So here you can understand the concept clearly. This is the signal diagram. So this is incoming amplitude modulated signal. The dotted line denotes the envelope of the AM wave.